and re-explain why there's certain values and why they work. Okay. And it's one of those weird things that you guys tend to have a bit of a moment to. It does. So what I want to do here is try to take away some of the fuzziness of this, if you will. Okay? What? Ooh! Hey, Devin, guess what? Let's make fun of Nelson. She brought the wrong stuff. Yell at her. Say, ha-ha. You got ripped up by Devin. You need to go get it. Well, Devin, that was so awesome. You said you suck. Devin, that wasn't very nice. You should apologize. Devin, you're going to be a politician, aren't you? You need to go get it. Right? Yes. I don't have time to write a pass. I don't have time to write a pass. Anyway, so here's what happens. One of the things that you guys have a tendency to forget is that you overlook the simplicity of what happens on quadrantals. Remember, quadrantals are the values that occur at 0, pi over 2, pi, and 3 pi over 2. Okay? When you have your quadrantals, you have specific values. When I move from the origin to the right, I move 1 unit. Am I moving an x or a y? X. So my ordered pair at 0 is 1, 0. If I move vertically, am I moving my x or y? Y. My ordered pair here is 0, 1. The reflection of it goes -1 and 0, and the reflection down goes 0, -1. Now, when we first started talking about trig of any angle, one of the things that we discussed was how to figure out what your radius was. Your radius was found by x squared plus y squared equals r squared, which meant that if we just took the square root of that, we were able to calculate their values of r. Now, after that, we then went into the idea of, well, cosine of an angle is x over r, sine of an angle is y over r, and tangent of an angle was y over x. And then obviously we had our reciprocal properties and so on and so on. So if I'm looking at, you okay? There's a lot of sickness going around. So if I'm looking at 0, cosine at 0 is x over r. Well, I have to figure out what r is. Well, at 0, I have 1 squared plus 0 squared. What's 1 squared? What's 0 squared? What's 1 plus 0? 1. And what's the square root of 1? 1. So that means at at 0, excuse me, I have an x value of 1, a y value of 0, and an r value of 1. What's my r value at 90? What's my r value at 180? Huh. And my r value here better be 1. So what's happening here by it being the unit circle, no matter what value I go out to the right, that's always going to be my radius. Those two values are always going to be equal. If I move to the right 7, what's my radius? 7. It doesn't change. Because then if I look at it, my cosine value is always going to be some value of x divided by r. Well, what's 7 divided by 7? 1. What's 1 divided by 1? So what's cosine at 0? 1. Yeah. So Jason, did I write x? I was gonna say I didn't accidentally write. My handwriting is awesome. Thanks. Shut up. It's better than yours. So So what's happening here is that you're using these values of x's and y's because when I have these values of r, when I divide by 1, does it change anything? No. That's why when we said that your x value is always your cosine, your y value is always your sine. So if I'm asking what angle has a sine of 0, I'm looking at, well, when I'm dealing with sine values, I'm between pi over 2 and negative pi over 2. Somewhere in this range, I have a sine value, I have an angle whose sine is 0. That happens to occur at 0. That's all this means. When you're working with quadrantals, you're working with ones and zeros for sines and cosines. It means where are you being placed on the axes. Okay? If you have a 1 for tangent, that means you're at a 45. Because when you're at a 45, your opposite and your adjacent are always the same value. If it's a negative 1, that means you're at negative 45 because you have an opposite and adjacent. One of them's positive, one of them's negative. That's how that works. Okay? So as you go back into use kids. As you go back into 18 and 19, I'm okay in assuming that those are okay. Bless you. 18 and 19, those okay? Okay. 20, is that okay? Are we okay with the idea that since tangent is 1, that means that the opposite and adjacent have to be the same? The only time that occurs is in a 45, 45, 90 triangle. It being a positive 1 means that it has to be in that first quadrant. If it was a negative 1, what quadrant would it have to have dropped to? 4, but with tangent, am I saying that that's going to be 7 pi over 4, or do I have to say that's negative pi over 4? Very good. That's the idea. You're using those parameters that we talked about of how things get placed in order to figure out the angles. Okay? So at sine, what angle has a sine value of 0? Means somewhere in between pi over 2 and negative pi over 2, I have a y value that's equal to 0. Well, y is 1, y is negative 1. Halfway in between, y is at 0, so my answer is 0. Yeah. And 0 degrees happens to also be 0 radians, or 0 pi. Yeah. Okay. 21, or that's 21, 22 is cosine at negative 1. Okay. Cosine at negative 1. When you have cosine at negative 1, what angle has a cosine of negative 1? Remember, cosine is found between 0 and pi. At 0, your ordered pair is 1 and negative 0. At pi over 2, it's 0 and 1. And at pi, you're at negative 1 and 0. Which of those three values has x negative 1? Where is that at? Which is what degree and or radian? And how many radians is that? Pi. So your answer here is 180 pi. Because that's the ordered pair that has a negative 1. Remember, cosine values are the only ones that you can get at angles that happen to be obtuse. Whenever you're trying to find an angle that has a cosine that's negative, that angle will always be obtuse because you're dropping to the second quadrant, you're working with a reference angle off the x-axis, so your terminal side comes up and over. Cosine are the only ones you'll ever get obtuse angles for. Everything else you're going to have 90 to 0, 0 to negative 90. Sines you include 90 and negative 90, tangents you don't because you can't divide by 0. Same thing goes when we have sine of negative 1. What angle has a sine negative 1? Again, that means you look at where you place sine values. Inclusive at pi over 2, inclusive at negative pi over 2. Ordered pairs, 0, 1. Which of those two has the y value at negative 1? At the negative pi over 2. So my answer for that would be negative pi over 2, negative 90 degrees. Radians, degrees. Okay. Uh, 24. I can't hear. I can't hear. What? Not necessarily. If you're given just like a 1 or a 0 or negative 1, it's sine or cosine, yes. If it's tangent, then it's going to be 45. Okay. Or it could be 0. There's a trick on when you get the ones that have the same root 3 over 3s. That means that that's been rationalized. Remember how we rationalize denominators? If you had 1 over root, if you had 1 over root 3, what would you do to that to rationalize it? You multiply top and bottom by the root 3, which gives you root 3 over 3. Well, what would you multiply that to unrationalize it? Over, right. Oops. It gives you 1 over root 3. Here's the trick. Anytime you have the same root 3 over 3 or root 2 over 2, the unrationalized version of it is 1 over root 3, 1 over root 2. It will always be that way. If you have root 3 over 2, that just meant it was a different angle. It means it was something you could figure out. But if you've got root 3 over 3 or root 2 over 2, the unrationalized of that will always be 1 over root 3 or 1 over root 2. Always works that way. If you're not sure, unrationalize. Just by doing what you would do to rationalize, honestly. Okay? So in that one, you had what? Tangent. So let's see. It's loud. Sorry. Tangent, this is basically the same thing as saying what angle has. Sometimes it's easier to write it this way. What angle has a tangent of negative 1 over root 3? You okay with that? Because I just unrationalize it real quick. Now, tangent being negative, that means I have to drop it down. So that's fourth quadrant. My opposite is the negative, because I moved down. My adjacent is the root 3. So if I moved down negative 1, my adjacent is root 3, what angle has an opposite of 1 and adjacent to root 3? 30 degrees. But since I moved downward, I moved down? Negative 30. Very good. Negative 30 there. So it's negative 30, or what's that in radians? What'd you say? Just pi over 6, yeah. I think it's like 5/7. What? Oh, yeah. I thought you said 7/6. I'm like, what's wrong way? A lot. Okay with that? And then cosine the negative root 3 over 2. That being a negative root 3 and a 2, I can place that one without having to worry about it. So when you place negative root 3 over 2, you've got cosine. That means it's got to be, since it's negative, it's got to go to the second quadrant. Your adjacent is the root 3. There's your negative, moving left. Your hypotenuse is 2. What angle has an adjacent of root 3? 30. The 30 does. So that means this is 30 degrees, and since that's in the secondary quadrant, that means that's its reference angle. So that places the terminal side there, which means what's the overall angle? 150. So it would be 150. Or remember that you are pi over 3 up. So that, I'm sorry, it's 30 degrees, so it's pi over 6 up, excuse me. Sorry. Jeez, that was a very, you were wrong, jerk face. It's okay. I'll have Devin beat you up. You gonna be my enforcer, Devin? I'll get you a good parking spot here. You're a hugger? No, that's fine, but you can be the muscle. All right. Oh, I didn't say parking pass. I said I just get you a good parking spot. No, I'm not buying his parking pass. I'll just spray paint your name on a parking spot. I didn't hear you. What? I don't know why I'm looking at the speaker. It's like you can see me looking at a speaker. If I look at the screen, you might see me better. Yes, ma'am. Because when you place second quadrant placement, means that's your reference angle. Since I'm in second quadrant with cosine, that means this has to be an obtuse angle. Cosine is the only one that when you're doing these working backwards, you're ever going to get an obtuse angle. Everything else is between pi over 2 to negative pi over 2 for sine, and then don't include the pi over 2, don't include that for the tangent. What's that? I wrote these out. What I want to do here real quick is just do a couple extras of these real fast. That we need to make sure we get this down pat before we do anything else. So take a few minutes. No. This won't take long. Yeah. So what I've done here is I just threw up on the board a quick 8 of these. It'll take about 10 minutes or so for us to check these things out. But I wanted you guys to see sometimes you can do multi-step with some of these trig functions. Let me slide these up real quick so you can see them a little better. Look at these last two on the bottom. If you look at the last two on the bottom there, one on the left says, what is the cosine of the angle that has a tangent that's equal to the square root of 3? Exactly. What you're doing here is you are working backwards. You're working backwards via the order of operations by working at the innermost parentheses and building yourself out. So it's asking you what is the cosine of the angle who has a tangent that's equal to the square root of 3. Yes, ma'am. You can just put them in your notes. I just wanted to go over these. I wanted you guys to keep this stuff so that way you can see more of these problems. Because quite honestly, we counted it out during the first hour. There's really only like 33 different angles you have to know that you can get. There's only a finite number of problems for working backwards because you're restricted within a specific domain. Okay. What's going to happen later, and Colby was asked about this yesterday, is what happens when you start getting into the other quadrants, and that's when we start working on tomorrow about equation stuff, where we're going to solve for all the possible angles that occur within a revolution of the circle. We'll do that tomorrow. But it still stems from understanding how do you start the problem, and then we're going to figure out what other quadrants things fall into. But again, today, I'm just working through this. Okay? So take a couple minutes and see how we do. Running a little short here. Tangent. What angle has a tangent of -1? -45. Very good. This one drops. Let me move these down a little bit here. This one drops. So you are -1, which means that's -45. otherwise known as negative pi over 4. Okay? What angle has a cosine of 0? Means if it's a 0, it's somewhere around here. That means your value of x is 0. Happens to be at 90 or pi over 2. Okay? So far, so good? Chimkey? What part? All of it. All right, we'll narrow it down then. All right, so here we go. Sine. Sine of negative 1/2. If sine is going to be negative, we know that it has to drop this fourth quadrant. But in this case, it's somewhere between pi over 2 and negative pi over 2. So if this is negative 1, if this is negative 1 over 2, that means my opposite is the negative 1. My hypotenuse is the 2. Which of the two special right triangles had 1s and 2s in it? The 30, 60, 90. The 45 had the 1s and the root 2s. Okay? So which of the two angles had the opposite of 1? The 30. So that means this one is negative 30, negative pi over 6. Because it's negative, one angle has a sine value of negative 1/2 because it moved down. Your opposite move, the y value moved down negative 1. Your hypotenuse is still 2. Cosine, negative root 2 over 2. That means that this one had to drop over to the second quadrant. Negative root 2 over 2, if I unrationalize it, that means it was 1 over root 2. So the root 2 is my hypotenuse, and the negative 1 is my adjacent. Which means this has to be a 45-degree angle. Second quadrant, if I'm in the second quadrant, I should probably show Devin this, it's easy to see. When I'm in the second quadrant, my reference angle is 45, which means then I have an obtuse angle coming across to it, which means my angle is going to be at 135. Or remember that I moved up a quarter pi, 3 pi over 4. Okay. Hey, Devin, you got the packet, right, bud? I wanted you to do did it make sense by saying doing the left-hand column in the last 3 pages? You're a smart man, Charlie Brown. You're welcome. Tangent. What angle has the tangent of root 3 over 3? That means it was rationalized. If I unrationalize that, I get 1 over root 3. Are you okay with that? So that means that in the diagram, it's positive, so it goes to the first quadrant. My opposite is the 1, my adjacent is the root 3. What angle is that? 30, which means your answer is 30, otherwise known as pi over 6. Remember, 30-degree angles go with the 6th, 60-degree angles go with the 3rd. Because 60 degrees is twice as much as 30, so 2/6 is 1/3. That's where that comes from. And then sine of 1/2. Just so happens that can be a triangle. Peace out, Kevin! What angle has an opposite of 1 and a hypotenuse of 2? Lo and behold, it's 30 degrees again. Means it's pi over 6. Okay. Now the fun ones. Devin, did you figure out those 2 fun ones before you ran? You get 1/2 for the first one? Okay, I think that's right. Okay. Now, what that means is ding, 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 ding. So anyway, what this is asking you is, what is the cosine of an angle whose tangent is root 3? 2 steps. Start of the inside out. Tangent root 3. We just did that, didn't we? Opposite, adjacent. What angle has an opposite of root 3 and adjacent of 1? 60. So that means that what is the cosine of 60? Well, cosine at 60 is 1/2. Oh. Huh? You got it? You can double these things all day long because you work backwards and you flip the triangle. Okay. And the last one. What angle? All right. What angle? Excuse me. What is the tangent of whose sine is √3/2? It's so hard to say it. It looks easier that way. Yeah. What's the tangent of the sine of the angle whose sine is √3/2? Oh. But I know that sine is opposite over hypotenuse. Oops. And I know that angle has to be 60. So if I know that this angle is 60, then I know that the tangent of that's going to be √3/1. So the answer is √3. What's that? All right. That's what I do. Sure, why not? Hey, I want you guys to do all of these. No, this is one of those things that it's always better to be over planned for some stuff versus under planned and have to scramble to find more stuff. So, if any of you ever have the inkling to become an educator, it's not a bad thing to follow because it's helpful to know that. Why not? You have to deal with people like you all the time, you make your focus with your classes and getting the racers to walk around and do things. Yeah. So on this, the last 3 pages are very similar to what we've been doing. I want you to do the left-hand column on the last 3 pages. Yeah, the rest of the stuff is good extra practice of all the stuff that we've been doing. So if you wanted, if there was a particular thing that you're still not doing all that great on, or you want extra practice, go for it. I'll have an answer key for this for you guys tomorrow morning if you want to check it. I'll probably just tape it to the window so you can look at it. And then that way you have extra copies to practice on. Okay? Yeah. Yep. Yep.
That's gonna be nice. I never got
The last 3 pages, the left-hand column. I mean, I can understand how you're hearing that. That was awesome. You just circled the ones not to do, is what you're supposed to say. I don't over. Jimky, you okay now? Try a couple and I will check it. What? I can't hear you. What? I don't understand the words that are coming out of your mouth. Very, very good. You're a fine human being.
So like